prove for any integer n squared plus 3n minus 5 is odd. If we take a look at it, the format n squared, so let's work on the scratch paper and see if we can figure out the proof. We know that if we want to prove a number is odd, we need the format 2 times integer plus 1. And there will be no problem of getting a 1. And what we can do is we can replace minus 5 with minus 6 and plus 1, because negative 6 plus 1 is equal to negative 5. So that will give us plus 1. And what's left will be n squared plus 3n minus 6. And the problem is, over here, we will not be able to factor out a 2. So we got the 1 we need, but we cannot get a 2 out of n squared plus 3n minus 6. Because in order to have a 2, not only you have to have the 2 here, but also a 2 here in front of n squared. But we don't have any of these. So in this case, we won't be able to do anything, but we have to do case by case. And so we're going to try to divide the numbers. We want to prove this is odd for any integer n. And this integer n right here, it could be an even integer, it could be an odd integer. So I'm going to do 2 cases. Case 1, n is even. And later we have to also prove n squared plus 3n minus 5 is odd for if n is odd. So if n is even, then we can assume we let n be 2k, where k is an integer. Make sure you write k is an integer, either using symbols or using a sentence. Now we're going to plug 2k into the expression we have, n squared plus 3n minus 5 equals, so replace the letter n with 2k plus 3 times, replace this letter n with 2k minus 5. And we simplify that. We're using algebraic formulas, 6k minus 5. And like I said before, if we try to get the format plus 1, we have to first come up with the 1. So I'm going to replace negative 5 with negative 6 plus 1. So negative 6 plus 1 is the same as negative 5. So we did not change the problem. Still the same. And now we can put all these first 3 terms together, because they all have a common factor 2. So I'm going to factor out the 2, and that will give me 2k squared plus 3k minus 3, and copy the plus 1. And this is exactly the format we need, 2 times integer plus 1 format. And this is odd. So now we proved. We started with the expression given n squared plus 3n minus 5, and we simplified it to get, we worked it out to get this format, which is odd. So that means we proved n squared plus 3n minus 5 is odd. And now we're going to, but this is only proved one of the cases, because we would prove this is odd if n is even. We haven't prove if this statement is true if n is odd. So in this case, we're gonna prove it similarly. So if n is odd, we let n be 2k plus 1. K is integer, and we're gonna replace n in the original statement expression with replace n with 2k plus 1. 2k plus 1. And work it out. So we're going to use the formula. So you can use the FOIL rule, 2k plus 1 times 2k plus 1. So you should be able to then combine like terms. This is what we're going to get, and distribute 3. You get 6k plus 3. Over here, I used the formula, and we got a trinomial immediately. If you don't know the formula, just go ahead and do 2k plus 1 times 2k plus 1. And let me put it over here. So you will have to do 2k plus 1 times 2k plus 1 and distribute, use FOIL rule, and combine like terms. Then you should be able to get that. Minus 5. So first of all, let's combine like terms. So we have 4k squared plus 10k and minus 1. And again, we need a plus 1. And so I'm going to replace this minus 1 with plus 2 minus, minus 2 plus 1, because negative 2 plus 1 will still give us a negative 1. And we can factor out a 2 out of the first 3 terms. And this is still odd. So now we proved n squared plus 3n minus 1 when n is odd, and also when n is even. And that's the only 2 cases we have. So that means we proved it doesn't matter if n is an even integer or odd integer, as long as it's an integer, then n squared plus 3n minus 5 is odd.